Hello good day viewers. In this tutorial we are going to find a solution to this system of equations systematically without substitution. We have 3m to the negative 1 plus 2n to the negative 1 equal to 2, and the second equation is 5m to the negative 1 minus n to the negative 1 equal to 3. And we are looking for the real values of n and m. So we are going to solve these equations in terms of m to the negative 1 and n to the negative 1. Then in the end we take reciprocals, so we don't have to substitute anything. So let me call this equation number 1 and call this equation number 2. All right, from equation 1, I would like to make m to the negative 1 the subject. So we have 3m to the negative 1 to the left, and this is equal to 2 minus 2n to the negative 1 as it crosses over, 2n to the negative 1. And since I want to make m to the negative 1 the subject, we can divide both sides by 3. Therefore, m to the negative 1 is equal to 2 minus 2n to the negative 1 divided by 3. And we can call this equation number 3. Then I would like to do the same thing to equation 2. So I will say from the second equation, we have 5m to the negative 1 equal to 3 plus n to the negative 1 as negative n to the negative 1 crosses over. Divide both sides by 5. We have m to the negative 1 equals 3 plus n to the negative 1 divided by 5. This is equation number 4. So observe, both equation number 3 and equation number 4 are written in terms of m to the negative 1. Therefore, we can equate their right-hand sides. This implies that 2 minus 2n to the negative 1 divided by 3 must be equal to 3 plus n to the negative 1 divided by 5, because all of them are equal to m to the negative 1. By cross multiplication, we take this and multiply by this. We set it to be equal to this multiplied by this, right? So 5 times 2 is 10. Minus 2 times 5 is minus 10, n to the negative 1. This is equal to, you take 3, you multiply by 3, you get 9 plus 3 times n to the negative 1. Collect the like terms. We have negative 10 n to the negative 1. If this crosses over, it becomes negative 3 n to the negative 1. This is equal to, already 9 is there. You take this to the other side, you have minus 10. This is minus 13 n to the negative 1, and this is equal to minus what? 1. Divide both sides by the coefficient of n to the negative 1. We have n to the negative 1 equal to minus 1 divided by minus 13, which means that n to the negative 1 is equal to positive 1 divided by 13. But remember, we are looking for n, not n to the negative 1. And n to the negative 1, remember, is the same thing as 1 divided by n. So by taking reciprocals of both sides, you have n equal to 13, right? Because 1 divided by n equal to 1 divided by 13, meaning that n is equal to 13. So now let us solve for m. Remember, from these two equations, either equation 3 or equation 4, they are all written in terms of m to the negative 1. So you can take one of them. Let me take the first one here, 2 minus 2n to the negative 1 divided by 3. So from equation 3, we have m to the negative 1 equal to 2 minus 2n to the negative 1 divided by 3. But we have n to the negative 1 right here, which is 1 divided by 13. So let us plug it there. We have m to the negative 1 equal to 2 minus 2 times 1 divided by 13 divided by 3. So this is what you need to simplify. We have 2 minus 2 divided by 13 divided by 3. 13 times 2 is 26, and 26 minus 2 is 24. So we have 24 over 13 divide by what? Divide by 3, which is the same thing as multiplying by its reciprocal, right? Let me write it. 24 divided by 13 multiplied by 1 divided by 3. And 3 here can go into 24 8 times. So this means that m to the negative 1 is equal to 8 divided by 13. But remember, we are looking for m, not m to the negative 1. So you can take a reciprocal of both sides. Therefore, m will be equal to 13 divided by 8. And this is the value of m. Now we conclude that n is equal to 13 and m equal to 13 divided by 8. As simple as that. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.